Good morning. I've picked out 4 questions for today's video and I'm going to work through them with you. So you can do it in a number of ways. You can choose to, when I show you a question like this first one, have a go at it yourself and then see the video as I work through it, or you can just work through the video with me. I'll be pausing at regular intervals and saying, right, now have a go at this. Of course, the other option is you might find the question really easy, in which case you can do it, check the answers. If you got it right, skip on to the next one. But let's go. Here's the first one. So we are dealing here with an acceleration formula, and it's a very simple formula. It's quite hard to perhaps pull it out, but what they're basically telling us is that A equals t minus 3. And we're asked to find V and distance, and I know that I can find velocity by integrating the acceleration, and then I can find distance by integrating the velocity. So to start with, to find v in terms of t, can I get you to integrate the a equals formula? That will give you a plus c equation, but we're told that when t is 0, v is 4, so you should be able to work out the value of c. I'm going to pause and get you to have a go at that. So increase the power by 1, divide by the new power, and just to clarify, I don't know how you choose to write that, but t squared over 2 is the same as a half t squared. They mean exactly the same thing, and sometimes I write it like this, sometimes I write it like this, some people prefer this, some people prefer this, but it's the same thing. So if you've been doing that, that's fine, you're okay. Minus 3 becomes minus 3t, but don't forget we're integrating here, plus c. We're told that when t is 0, v is 4, so 4 equals 0 squared over 2 minus 3 times 0 plus c, so you get that c is 4. So that is your answer to part A, v in terms of t. We're then asked to find the values of t when p is instantaneously at rest. So we've got a formula for the velocity, and we know that it comes to rest when that equals 0. So the answer to part B is just the solution of that problem. So it might be easier to use the alternative form of writing that. T squared over 2 is the same as a half t squared, and I'm just going to solve that with my calculator. Go for it. Okay, so I just typed in A is a half, B is minus 3, C is 4, and that gave me my 2 answers. Just a quick check that those are 2 valid answers. Yeah, we've got no range of t that we're told to consider. So that's the answer to part B. And then the distance between 2 points. So if we want to work out distance, we integrate velocity. So I need to integrate this formula, and now I'm doing it between 2 values. So that's between 2 and 4. I'm integrating t squared over 2 minus 3t plus 4. T is the variable, that's what dt tells us. So see if you can do this. So you're going to integrate it, and then you're going to substitute in t is 4 and t is 2. One take the other will give you your final answer. Just before we do that, we've integrated twice now, haven't we? We integrated a to get v, but we didn't substitute values in there. That gave us a formula with a plus c, and we substituted in a single pair of values to work out the value of c. So that's one application of integration. Here we're using integration to work out the area under the graph, so we are substituting in 2 values. So we've integrated a to get v, and we're now integrating v to get distance. Pause, have a go. So increase the power, divide by the new power, so it becomes t cubed. If it's already divided by 2 and then you divide by 3, you get divided by 6. Increase the power, divide by the new power, 4 becomes 4t. And then I'm substituting in 2 and 4. So I just used my calculator. Remember the trick I showed you? I put 4 in the memory X, and then I just typed in this using x instead of t and pressed xe, and it worked it out for me. And then I went back up here and replaced the 4 arrow x with 2 arrow x, pressed xe, it worked it out for me again. So you get minus 2/3, which just remember means 2/3 in the negative direction. So the actual distance is just 2/3. Okay, here's the next question. So the second question is from the mixed exercise at the end of chapter 11. So this is about a maximum speed. Now, if we were given a formula for v equals, and we could sketch what the speed looks like, don't know what it looks like, and we wanted to find the maximum value, we would differentiate and ask, when does dv by dt equal 0? But we're not given v equals, we're given a equals, and we know that acceleration is what you get when you differentiate velocity. So this formula here for a is already dv by dt. So we're going to need to work out v equals in a minute, but actually all we need to do in part A is to ask, say we are going to get a maximum value when dv by dt equals 0. We then had to realise that that was dv by dt. It looks like a quadratic, but you can actually solve it without thinking of it as a quadratic. So just see if you can work out the value of t. There's only one value, so just think about how you're going to do that. I'll pause and have a go. So t could be plus or minus 2, but it can't be minus 2. So maximum velocity occurs when t equals 2, but the question doesn't say when does the maximum velocity occur. It says what is the maximum velocity. So we are going to have to take our a equals formula and integrate it to get a v equals formula and substitute in t is 2 to that. And we have a problem when we integrate that, because if I integrate that, I've got that pesky plus c there, and we don't appear in the question to be given a pair of values to substitute in. Except we are, because we're told a particle starts from rest. So that means that when t is 0, v was also 0. And that means that if I substitute that in, c is 0. So when that is 0, 8 lots of 0 is 0, minus 2 lots of 0 cubed divided by 3, so that's 0, so c is 0. So the velocity is just that. And we're going to substitute in t is 2 to work out the size of that velocity. So that's 16 minus 2 cubed is 8, so that's minus 16 over 3. And I'm going to stick with fractions because that's a little bit easier. So that's 32 over 3, which is 3 and which is 10 and 2/3, but I'm going to leave it like that. And it's velocity, and we're dealing here with meters and seconds, so that's meters per second. Quite a lot of work there for that part A. So the story so far, we have started with a formula for acceleration, which we've integrated to get a formula for velocity, and we used both of those to answer part A. In B, we need a formula for distance, and we know we get that by integrating our velocity formula. And we are now asked to find distance between two values. The first 2 seconds, so that's going to be between t is 0 and t is 2. So I'm going to integrate that, and I'm going to substitute in 0 and 2 to work out the answer. Let me pause and you have a go. Okay, so 8t becomes 8t squared divided by 2, which is 4t squared, and 2t cubed over 3 becomes 2t to the power of 4. Well, if you're already dividing by 3 and then you divide by 4, you're dividing by 12. Actually, I could have simplified that to t to the power of 4 over 6, but there we go. Plus c, but of course that c disappears, so we don't worry about it from now on. And I used my calculator to work out the two values, and that gave me my distance. Okay, another question from the mixed 11 exercise, question 7. Again, we're given an A equals formula, and we're asked to find a V equals formula, and then we're asked to find an S equals formula, and we're also asked about when it's instantaneously at rest, which you may remember is about when the velocity is 0. Are we given a pair of values to help us when we integrate this to get rid of the plus c? Well, we are. Look, at time t equals 0, the velocity is 6. So when t equals 0, v equals 6. So have a go at part A firstly. Take your formula for acceleration, integrate it, which will give you your formula for velocity with a plus c, and substitute those values in to work out the value of c. Okay, increase the power, divide by the new power, increase the power, divide by the new power, simplified it. If t is 0, v is 6, you end up with c being 6. So that gives you your formula for velocity. So in part B, we want to know about the displacement. We've worked out a formula for velocity. So we know that to get distance travelled, we integrate it. It's not the velocity between 2 points, so I know I'm going to get a plus c in there when I integrate this. And we've got to try and work out if we've got any information up here which will help us work out the value of c. Have a go. Okay, so I just integrated and I had a plus c in there because I'm not actually substituting values in to work out a distance between 2 points, but I did, in order to work out c, I did need to find a t and s value, and here it is. At time t equals 0, the particle passes through the origin, so it's when t is 0, the distance is 0, and if you substitute that into this, you get 0 equals 0 minus 0 plus 0 plus c, so c is 0. So that is your formula for displacement. It's not how far has it travelled after so many seconds, it just wants a formula for displacement in terms of t. Okay, on to part C, the values of t at which the particle is instantaneously at rest. So we've got a formula for acceleration, we've got a formula for velocity, and we've got a formula for distance, all derived by repeated integration. But which of them are we going to use for this question? Well, hopefully you remember it's this one here. When it's at rest, velocity equals 0. So for part C, I'm going to say, right, okay, when does that equal 0? Just going to move along a little bit to the side. 0 is my friend, so if I double everything here in this equation, this looks a bit nasty. We've got not a quadratic, but a quartic, an equation with power of 4 as its highest power. But this is actually one of those quadratics in disguise. So I'm going to replace t squared with y, and that means t to the power of 4 becomes y squared. So I get y squared minus 8y. I'm then going to solve that. I mean, that's one that's quite nice and easy to solve by factorising, or you can use your calculator. That will give me my y values, which remember will be t squared values, so I square root those to get the t values. I'm definitely looking for values. See if you can finish that part off. So remember, this was our velocity formula, and we asked when does it equal 0. Our calculator will actually solve quartics, but it's one of those things that we're not allowed to use our calculator for. We can use it to check. So instead I doubled everything, recognised it was a quadratic in disguise, so used a substitution, solved it, could have used my calculator, just wanted to keep my factorising skills honed, and that gave me my t squared values. I then square rooted those to get 4 possible values of t, but only the positive values make any sense in this question. So we've got t is t is the square root of 2, and t is the square root of 6 seconds. And this fourth one actually is probably the most straightforward, although the numbers are quite fiddly. So we are given a formula for distance, and we have the graph for distance plotted for us, and all we want to know is the maximum minimum displacement, the maximum minimum height. So we're looking for this point here and this point here. So I don't need to worry about velocity or acceleration. I just need to differentiate this and find the turning points. Now actually, ds by dt is a formula for velocity, isn't it? But we're using it in a different way here. We're using it to find maximum and minimum. We did that last Thursday. A little trick here though. This formula here looks really fiddly because we're dividing everything by 50. Are you happy with me rewriting it like this? And when you differentiate, if there's a coefficient in front of the term, it'll stay there. So actually I can differentiate this by just differentiating that. And the 1 over 50 will still be multiplying every term, but I don't need to differentiate that. That's just a multiplier, it's just a coefficient, and it's quite a useful trick, and you'll see why it's particularly useful in this case. So we're differentiating, always got to be clear in your mind, haven't you? So multiply by the power, reduce the power by 1. Multiply by the power, reduce the power by 1. Multiply by the power, reduce the power by 1, and that term will disappear. Now, turning points are when that equals 0, when the gradient ds by dt, or the velocity in this case, equals 0. So I just ask, when does that equal 0? And hope you can see what my next step will be. My next step will just be to multiply both sides by 50. 0 is your friend, so that stays as 0, and that means that you just get this. This is a problem, isn't it? It's a cubic. I can solve quadratics, but I can't solve cubics. Could anyone spot how I can start? Well, hopefully you can spot that I can write that as t times 4t squared minus 36t plus 56. And I know therefore that one place where this will equal 0 is when t equals 0. And if I look back at my original graph, yeah, it looks like I had a turning point at t equals 0, but that's not what we're interested in. Instead, we're interested in the solution to this bit, aren't we? And for that, I'm going to use my calculator, and I can just put it into equation mode, and it will all be good. Polynomial 2, so we've got 4 minus 36 and 56. And so my two solutions are 2 and 7. And are we asked to find the time of the maximum minimum? No, we're not. We're asked to find the maximum minimum height at those times. So all I now need to do is go back to my original s equals function, and I can substitute in these two values. And I can use the trick that we use with integration, where you can set x to 2 and then type in the original function using x's. See if you can calculate for me the maximum and minimum height by working out the value of s when t is 2 and when t is 7. So here's my original s equals formula. We know that it reaches its maximum height when t is 2 and its minimum height when t is 7. So those are the values I get, and I just used my calculator for that. I didn't do anything manually at all. Now you might think, oh, do you know what? I'm just not happy that these numbers, they just don't look nice enough. So I want to check on my calculator. I mean, we already know, don't we, what the graph looks like because they give it to us in the question. And so I can now use the answers I've got to that previous question to say, right, I reckon the maximum is when t is 2 and the displacement at that point is 8.64, and the minimum is when t is 7 and the displacement is at 1.14. So that's what I think I've worked out so far. So let's now type this function in. I can either do it like this or as 1 over 50 times that, and let's type that in. There we go. And if I draw that, and if you see, I've set my axes up. So x, I've gone from 0 to 8 because that's what I had. And from y, I'm going from 0 to 10. There we go. And let's just go to my favourite button, gsolve. Let's check the maximum. So x is 2, y is 8.64. Bingo. And then the cursor button takes me to the, oh no, there's only one maximum, so that's fine. So back to gsolve, minimum, x is 7, y is 1.14. So I've confirmed my answer using my calculator. I can't use the calculator to work out the answer, but I can confirm what we've seen. Okay, I will leave it there. There are 4 quite tricky questions, but that brings us to the end of mechanics. Not to the end of my videos though, because we're going to do 2 more weeks of proof, which brings us back to pure, and it's just a bit of revision of something you did earlier in the year. Take care.